Welcome to the Machine Learning course, using Google Colaboratory in Google Drive, and libraries like NumPy, Pandas, and Scikit-learn. Right-click, select More, then connect more apps, search for Colab, click Install, and then confirm by selecting Continue twice. When installation finishes, it asks if we want Google Colaboratory as the default app to open files, so we simply select OK. Close and right-click again, then go to More Google. Colaboratory should appear. Select it and wait for Colab to fully load. Zoom in to see the File menu to manage, edit, view, insert to work in Colab, Runtime for settings as well as tools and help. Below we have a ribbon of options regarding the code and text within the notebook, plus the Connect and Configuration options. At the bottom, if we wish, we can enable Gemini to help us with coding, and we have a cell provided to write our own code. In this first example, we use the print function to show a message in the console. It is one of the first commands used in Python. The text "Hello World" is the classic program to verify the environment works correctly and our first code runs without any errors. If we position ourselves above or below the code cell, the option to add a code or text cell appears. Let us add a text cell. We write the example name and add the hashtag sign to indicate it will be a title. The markup language used is called Markdown. At the top, we have the notebook name, which we can change by double-clicking it and typing a name appropriate for the example. When producing a change, such as executing a cell, we can see that it performs an automatic save. Check the folder to verify it. Close the notebook to load it again and check that the saving was done correctly. In the folder, we view files as list or grid. Open the notebook again. The connection is still active and we can see how much memory and disk it has. It is even shown as a graph. Besides information, we can set the runtime type. For example, we change the language to R or Julia or use a GPU with CUDA. It also tells us we can buy extra compute units for a GPU. Furthermore, we can select the specific version of the runtime to use. Add a text cell below at a title saying Types and Operations. After changing cells, we can see the title formatting. If we want to add a subtitle, just add more hashtag signs to do it. Now we create a cell below, but for code for another example. Now we create the variable named A and assign it the value 10. We also create a second variable named B with the value of 5. Then we create a string variable using quotes. Like the Hello World example, we save a decimal number in the variable pi. If we run the cell with the play button or with Ctrl-Enter, we see it prints nothing because we did not use print, but no errors. With the print function, we can print not only strings but also operations between variables. We will print the sum of A and B. We can also use the same print function to show the result of any operation. For example, the multiplication between A and B values. We run the cell and observe the results of the sum and multiplication. In Python, spaces after the function are optional. The type function returns the type of data stored in a variable. This allows us to verify what class of information we are using. Now we check the type of the variable named name with the type function to see how Python interprets the content stored inside it. We can also check the type of a decimal variable using type. Python automatically identifies this data type. By executing the cell, we observe the three data types we requested via type and print. We see an integer, a string, and float. Now we create a code cell, and in the middle we create a text cell. As we can see, the cells move down. Add the title lists. A benefit of cells is that they are cumulative. This means that in a lower cell, one can use variables created in an upper cell. Here, we create a list named values that stores 5 integers within a single data structure that is both ordered and indexed. When printing the full list with the print function, Python shows all elements in exactly the order they were stored. The indices are the positions of elements. In Python, the numbering always starts from 0. Using it, we get the first item. Likewise, we can print any position of the list. When creating a text cell, we can delete it by using the trash can icon instead. In case an error was made, we can then add the appropriate cell, for example, a code cell to organize the code properly. In this new cell, we can reuse the variable values with the print function. As mentioned, this refers to the variable created earlier. But the use of lists in Python has certain limitations. To perform some operations, it is necessary to use other external libraries. For example, if we want to multiply the current list by 3, in theory, we expect it to take every list value and multiply it. Intuitively, that should be the behavior of operations on data structures. However, the lists do not work in that specific way. After executing the cell with the operation on the list, we see it printed many values instead of the individual operation result. In reality, it copied the list 3 times. That is why many more values appear compared to the original ones. This can be a problem. Since the operation is not applied to each list element, if we want that behavior, we must use a loop to iterate every value. We delete that cell, and in the next videos we will see some libraries needed to perform operations efficiently without using loops. These are the examples for this first video. We close the notebook and return to Google Drive, where we see the saved notebook. The use of Colab greatly facilitates programming with Python, as we do not create environments and notebooks include explanations. Up to here we leave this video. If you liked it, subscribe, leave a like and activate notifications. See you in the next video.